We actually started down the road of hyperconvergence at BCD, but we realized that there were several things in a true HCI environment that were not only cost prohibitive, but performance prohibitive when you look at a true HCI. So the concept is we create numerous servers that share resource pools, that have the ability to move the VMs between nodes on failure, that are going to retain the data in the event that a node fails, that are going to distribute or share resources, and more importantly, get a more efficient use of the resources that we're actually paying for by virtualizing. So in a traditional HCI environment, you will see that you have your VMs that reside and the operating system, the VMS, as well as the data store, meaning where the video is stored into a virtual SAN, a virtual storage area network that's comprised across the servers in that cluster. This is where it becomes problematic. You have to create a two-tier environment when you build the virtual SAN out, meaning the first tier is high-speed SSD drives, but then a second tier of rotational drives actually expand the storage out. All of that works great until one of the nodes goes offline. As you start to reach the higher capacitance or the higher bit rates and one of the nodes fails, the VMs will actually, or the machines will move to the remaining nodes. But in essence, what you're doing is you're taking the IO capacitance that was expected out of those nodes and dramatically increasing it while reducing the spindle count that resides underneath it for storage. So by doing that, you can actually see that your retention time can be affected, as well as the overall throughput that you could get. So when we went through and we did testing and validation of this, what we found is as you get to the higher bit rates of these clusters and a node or two nodes were to fail, in order to maintain the throughput or the bit rate that's coming in, more often than not, the entire vSAN cluster could not represent multiple tier. It could not be a tier of SSD drives followed by rotational. It had to either be all PCIe or it had to be all SSD drives in order to maintain the IO throughput that you needed to service that cluster. It's not that you can't do it, it's that it becomes incredibly expensive. If you look at a solution that requires 2 petabytes of storage, going back to a customer and saying, you're going to have to fill all of those servers up with 2 petabytes of SSD drive storage is just an insane cost. You do have people on the market that are doing that. However, we didn't find that that was the best way to approach this. What we created is we created what's called a hybrid hyperconverged infrastructure. And the hybrid hyperconverged infrastructure looks at what requires the high speed. We already know that storage area networks or SANs have 5 nines of availability, and in a razor-coded environment, I can get 9,600 megabits per second across that SAN node with a petabyte of storage or more. So what's important as these things fail? What are the choke points? What needs to run inside of that SSD? And it came down to the actual virtual machine itself. The operating system needs to be on that SSD, the VMS platform, and the databases associated with it. So rather than trying to create massive amounts of SSD storage across this clustered tier, what we did is we built SSD storage into the cluster for those critical components. And those components don't take a lot of space. The virtual machine itself, the actual operating system, the database, and the VMS all reside on the SSD. And it's a shared SSD paradigm. So if any node fails, that particular VM will simply move to the remaining nodes. But because I'm not storing my actual physical security data there or my long-term retention, I don't have the same IO problems I would have with a traditional HCI or HCI solution. When my VM moves from node 1 to node 3, it simply reboots, the VM comes back up, and it makes its iSCSI connection directly back to the SAN storage. At that point in time, it has access to all the data it stored originally, plus it begins to record new data coming in. You wind up with about a 2 to 3 minute gap as they vMotion or as they move between nodes, but it's completely unattended in how it operates. And when you compare that cost-wise, you get everything that you would get in a true HCI environment, but it's a lot more cost-effective while leveraging traditional storage or traditional centralized storage like SAN and NAS.